All right, so now we're going to get after some practice problems related to KB and kind of navigating that. So one example is calculating the pH from molarity. Find the pH of a 0.025 molar ammonia solution. Okay, KB for this NH3 is 1.8 times 10 to the negative fifth. Good thing to note, that times 10 to the negative fifth, we don't have to do the quadratic. Now let's look at our reaction. Our reaction is effectively, or our reaction is NH3 plus H2O. Now it's going to produce NH4 plus OH minus. Okay. Now our initial concentration of ammonia is 0.02 0.025. I'm going to skip H2O because do we even include that in our expression? No, we don't. What's our change and what's our equilibrium concentration? That's what we want to know. Our initial concentration of ammonium is 0, hydroxide is 0. We subtract X, we add X, and we add X. And then at equilibrium we have 0.025 minus X, and we have X, and we have X. Okay, so our KB, that equilibrium expression, or that base constant, is 1.8 times 10 to the negative fifth. That is equal to NH4 plus OH minus divided by NH3. Okay. Now, I'm going to substitute my values, X and X, divided by this 0.025 minus X, but I don't have to worry about that minus X because it's going to be negligible due to this times 10 to the negative fifth. So I'm going to write 0.025. Okay, so what I'm going to do there is then the algebra where I get 1.8 exponent to the negative fifth times 0.025, and I get 4.5 times 10 to the negative 7. So this is going to give me, I'm going to rewrite this as 4.5 times 10 to the negative 7th is equal to X squared, because I multiplied 0.025 by 1.8 times 10 to the negative fifth. And that got me the 4.5 times 10 to the negative 7. I'll take the square root of each side. And that's going to give me X is equal to 6.71 times 10 to the negative fourth. Okay, noted. What did I just solve for? I solved for X. So this gives me my hydroxide concentration. Okay, so one thing that I remember is that I have in my back pocket Kw. Kw is equal to my hydroxide ion concentration times my hydrogen ion concentration. Well, I know that Kw is also equal to 1.0 times 10 to the negative 14th. That's equal to 6.71 times 10 to the negative fourth times X, which is my hydrogen ion concentration, which is what I'm effectively solving for and plugging that in there. And so what I can say, actually, you know what, I'm going to go ahead and I'm just going to put this as H plus. Okay, I could rearrange this and say my hydrogen ion concentration is equal to 1.0 times 10 to the negative 14th divided by 6.71 times 10 to the negative 4th. Okay, so I'll plug that in. 1.0 exponent negative 14 divided by 6.71 exponent negative 4th gives me my hydrogen ion concentration of 1.49 times 10 to the negative 11th. Now, luckily, I can plug this right in. It's already in my calculator. I'll take the negative log of that, and I will get negative log of this number is equal to 10.83. So it's a very basic pH. How did I do that? Well, I went through a couple of different steps. I started out with my expression right here. I did the ice table. I solved for X, which is my hydroxide ion concentration. I related that to Kw, then related that to my hydrogen ion concentration, which that gets me ultimately to my pH. Now there's lots of homework problems just like that. Given a pH, what is your pOH? Given your Kb, what is the Ka? Given your Kb, what is your hydrogen ion concentration? Now, another similar problem to that. What is the molarity of an aqueous ammonia solution that has a pH of 11.17? Okay, so we've got a Kb here. We have a pH of 11.17. So what does that get us? Okay, what can we really do with this question? Now, I know that with my pH 11.17, I can say 10 to the negative 11.17. I can say that. 10 to the negative 0.117. Okay, so 11.17. And I get a hydrogen ion concentration of 6.76 times 10 to the negative 12th. Okay, that's my hydrogen ion concentration. Okay, where I want to go with this is I want to go to, well, what is my OH concentration? Because that's what's going to be most helpful for my Kb and using that Kb. Because what I can do now is I can say 1.0 times 10 to the negative 14th is equal to, and I'm going to skip a step a little bit. I'm just going to take my hydrogen ion concentration and put that below here. 6.76 times 10 to the negative 12th is equal to my OH concentration. Okay, so 1.0 exponent negative 14 divided by 6.76 exponent negative 12, and I get a hydroxide ion concentration of 1.48 times 10 to the negative, we're looking at a negative 3 there. Okay. So there's my hydroxide ion concentration. That's at equilibrium though. What I need to do is I need to kind of work backwards. And basically what I'm looking at is an equation that looks like this. NH3, NH4 plus OH minus ICE. I know this number is 1.48 plugs in here. It also plugs in here. This is 0, this is 0. So then I'm looking at X minus 1.48 times 10 to the negative third. 48 times 10 to the negative third here. 8 times 10 to the negative third. So now what I can do is I can erase all this, and I'm going to say my Kb, which is going to be, I'm going to write the Kb expression over here, is equal to NH4 plus OH minus divided by concentration of NH3. Now that concentration of NH3 is what I'm really trying to figure out, but I don't know it. However, I know what goes here and I know what goes here. So I'm going to say 1.8 times 10 to the negative fifth is equal to 1.48 times 10 to the negative third squared over, I'm going to say x minus 1.48 times 10 to the negative third. Okay, so now what I need to do is I need to solve for this x. I'll do my algebra and rearrange this. And what I'll do is I'll get it set to be x minus 1.48 times 10 to the negative third is equal to 1.48. I'm plugging this into my calculator. 1.48 times 10 to the negative third squared and that's going to be 2.19 times 10 to the, let's see, we're looking at a minus 6 there, divided by 1.8 times 10 to the negative fifth. So divided by 1.8 Okay, so now what I'm looking at is x minus 1.48 times 10 to the negative third is equal to 0.12168, and then it just goes on 8 repeating. So to that I'm going to add the 1.48 times 10 to the negative third. So I'll add plus I'm going to get X, which is my molarity of ammonia, and that is equal to 0.123 molar. Okay, there's a lot more involved in that problem than the previous one, but I hope that was helpful.